Hi folks, this is part 2 of the level up challenges. Yesterday's challenge was to build a basic borrowing and lending contract that utilised ETH. And today's one is, it's a similar type of contract, but instead of using ETH or a message of value to transfer in the funds, actually interact them with ERC20 tokens. So it's going to be lending and borrowing with ERC20 tokens instead. So what I'm going to do is I'm going to set up the project, forge an it. Okay. First thing I'm going to do is install the Open Zeppelin contracts, and the reason for that is that we're going to be interacting with ERC20s, Open Zeppelin, Open Zep, and contracts. I think that's right. Yep. Give that a second to install. Okay. I'll just do a remapping in here. Mappings equals square brackets in here. It's Open Zeppelin 2Ps contract, and it goes to lib Open Zeppelin contracts 1s. Okay, I think that's correct. And what we're going to do now is we're just going to touch source. We're going to do we call it token lending. That's sol. And I'm also, for later on, just for testing the contract, I'm going to touch env. Okay, let me see now. Okay. And I'm actually, because I'm going to deploy it to the local Anvil blockchain, so I'm going to need we're going to need I call it my token. So, because we're going to need a token to deploy. I'm going to get rid of these temporary files as well, or these template files, I should say. So counter. Okay, that's grand. So on token lending, I'll do private Solidity. Do MIT. We're just going to do the version as 0.8.20. Okay. Contract. Token lending. Save that. So first thing I'll do is import the ERC20. ERC as interfaces, and we're looking for ERC20. There we are. Okay, so we're importing the ERC20, which is the interface for the ERC20 tokens, because we're going to be interacting with this token that we're going to deploy locally on our blockchain. So I'm going to just copy out from the brief on what to write in the contract, again like the other video. Copy this. And I'm going to paste this stuff in here as comments, so we just have a bit of structure. Do this. There we go. Grand. Okay. So the first thing we're going to need is we're going to have a token that's going to be used as collateral. So I'm going to do ERC20 public token, and then that's going to be a token. And what we're going to do is we're going to pass that in using our constructor. So it's going to be address. Let's go to token. And then in here, we are going to set the token that we've declared up top. As I'm going to do, we'll wrap it like this. The cast, I should say, this actually should be token, not tokenet. Token. There we go. Token. Okay. Public token. You see. Oh, underscore. There we go. Okay, so we're in a constructor. We're passing through an address of the token that we're going to deploy. We're going to deploy this my token here. We'll deploy the my token. We'll get the address back, and then we're going to pass it in to the constructor of the lending contract when we're actually deploying it, and then that will set our state variable here as the address of the token contract. So let me see. I'm just going to minimize the shell. Track balances and borrowed amounts. Okay, so we're going to do, actually, we'll just start up here. The state variables. And I'm going to do, and we'll call this balances. Balances. So first thing is mapping. Similar to yesterday, it's going to be an address. Going to UN256 public. And we will call this, we call it token collateral. Balances. Collateral. I hope I spelled that correctly. Then the mapping, the second one is going to be in the same again, an address going to UN256 public. And we call this token borrowed. Balances. And then we will also do, we'll do UINT 256, and we call it public, and we call it total tokens in contract, just in case we need that. Okay, so we have them done. Delete that. Then we're going to do our 4 functions. Okay, so our first function is deposit. So again, it's a very similar structure to the other one, to the ETH only contract, but because we're using tokens, we're going to need to interact with the ERC20, with the ERC20 interface in order to transfer between, into the contract and back out. So, so we're doing UINT 256. So deposit is going to be an amount. So we're going to deposit an amount to public. Okay, and the first thing I do is going to check amount is greater than 0. Say require the amount to be greater than 0. Otherwise, please deposit an amount greater than 0. Okay. Okay. So I'm gonna just so what we're gonna do, transfer tokens into contract, or I should say transfer tokens from message.sender to contract. And we're gonna do with this now. This is as we've declared this in ERC20 token up top. It means that we're going to be able to use the functions on it. So transfer from message.sender address this and amount. So what's happening here, wait a second, oh, I spelled it wrong, that's why. Transfer from, okay. So what we're saying here is on this token we want to call transfer from, and we want to transfer from message.sender into the contract at this amount. Now the only thing is, currently the message.sender will actually be called as from this contract. So the message.sender will be this contract. So in order for that, we have to set an allowance. So we really need, before anything happens, we're gonna have to have something here. So this will have to be called in advance. Say EOA should call approve on the token contract to allow lending contract to spend, transfer its tokens. So that'll have to be done in advance. So that's why when you're using Uniswap or something like that, or Aave, you'll get an approval in MetaMask first, because it's actually what you're doing is interacting with the token contract and saying, yes, let Uniswap or Aave take control of these tokens and do whatever is needed with them. Okay, so we'll have to do that we'll do that as part of we'll use Cast to call my token and call an approval of my token and allow it afterwards. Okay. So once that's done, we'll say that we've all that done. Excuse me. Update balances. So token collateral balances of message.sender. So he's depositing. So plus equals. That's going to be the amount. And then we'll do total tokens in contract. We'll do plus equals amount. And then we're going to do emit event. Emit user has deposited tokens. There we go. back up here. Do events. Okay. So that's our deposit function done. So for our withdraw function, withdraw. It's kind of again uint 256 amount public. There we go. And the first thing again, check amount is greater than 0. Require amount greater than 0. Otherwise, specify an amount to withdraw. Okay, and we'll also do one more check here. We'll call the check that user has an existing balance to withdraw. So we'll say require. We're going to say token collateral balances of message.sender to be greater than or equal to amount. So you're going to say that amount, spell that correctly. So what you're saying here is you're making sure that in the contract their balance is greater than or equal to the amount that they're trying to withdraw. So you don't want them withdrawing, 1,000 if they only have 50 in the contract or whatever. So that's fine. And say, and if not, then we just say you do not have enough tokens deposited to withdraw amount. Okay, that'll do. Okay, save that. Now what we want to do is we'll do the update balances now. So we're withdrawing from the contract, so we're going to say token collateral balances minus equal amount because we're taking it out. Oh, yeah, my bad. Message.sender. So total tokens and contract amount transfer tokens to user, and we do token.transfer message.sender amounts. So again, we're interacting with the ERC20 or the ERC20. We're calling transfer, saying send the message.sender this amount. And because the contract, we don't need to do any proof because this is the contract calling it. Emit event. Say emit user has withdrawn tokens. Tokens. There we go. Okay. Oh, I better just quickly do the event up top. Yeah. Event. Okay. It's that one. Now we'll do the borrow function. Same again. Uint 256 amount to borrow. Public. Okay. Do the same again. Check amount is greater than 0. In fact, let's copy that. We say here, please specify an amount to borrow. Okay. So it's doing more. So user can only borrow as much as they have deposited as collateral. So you require token collateral balances of message.sender has to be greater than or equal to the amount they're looking for. Otherwise, you can't borrow more than you have as collateral. Collateral. There we go. Okay. Then with the update balances, the token borrowed balances of message.sender. So we're gonna add on the amount to the token borrowed, and the tokens, what did I say? Token total wasn't token total tokens in contract are going to be reduced by the amounts. Okay. Transfer tokens to user. So again, similar to above, token transfer message.sender. Yep, and amounts. Okay, then emit event. Emit user has borrowed tokens. Okay, and we will pop that up top. There we go. And now we are on to our last one, which is our repay function. So we do a function, repay, again, uint to 56 amount to repay, public. That's about right, repay, yep. And okay, again, check that the amount is greater than 0. Let's fix those up there. And we'll do one more. So we check that the user has an outstanding loan. So require, and we're going to say that they have some in their token borrow balances. So they have to have something in here to repay, or else it's kind of pointless. And we say that it is greater than the amount. You do not have an outstanding loan. Okay, that's fine. Then we do transfer tokens to contract, which is going to be token.transfer from, and again message.sender, transfer from the message.sender to address.this contract, and this, and that's the amount we're looking to transfer of the ERC20 tokens. Again, as with up above, we're assuming that the approval is already been done in the EOA. 1 second. Get this back down. There we go. And then we do update balances. So again, message sender. So the borrow balance, they're repaying, so the borrow balance will be less. The amounts total in contract should be added on to by the amount. Emit event, emit user has repaid loan. Should really be repaid some of the loan, maybe, because they mightn't be repaying the entire loan, but we're just gonna build it out as is. Okay, so that's the bulk of our contract done there. What we're going to do is we're going to deploy a token. We're going to spin up Anvil. We're going to deploy a token to Anvil, and we're going to use that address and pass it into the constructor of this token lending contract when we're deploying it to the local Anvil chain, and then we're going to test it. So if we switch over to my token, I'm going to paste this in here. So I got this from wizard.openzeppelin.com. It's just a basic ERC20 token. I'm going to save it there. And what I'm going to do now is I'm going to spin up Anvil, because we're going to need a few things out of Anvil. So let me see. New bash Anvil. And I'm going to open the env file. Okay. Now. Okay, so first thing I'm going to get is this, and I'm going to call this deployer pk deployer address. It's going to be that one. And I'm going to do token owner pk be the second one of these. Token owner address. It's going to be the second one of these. Save that. What I'm going to do then is our lending contract address. And we'll say our token contract address. That's that. Okay. Switch back over here. So the first thing I'll do is deploy the token to Anvil. So source, and it is my token.sol, my token private. Actually, I didn't load the env, so source.env will load those variables. So forge, create, source, my token.sol, my token private key. And the private key is going to be the deployer. No, it's not. It's going to be because they're deploying the token. So it's going to be token owner PK. And there's no constructor in the token, I don't think. Okay, that's fine. So this is our token address here. Put that there. Save that. Okay, so we need that. So what we're going to do now is we're going to do forge, create, source, and it is what we call a token lending.sol, token lending, and the private key we're going to use for this one is deployer PK. We need to have the constructor args, and the constructor args are going to be, so if you look in here in token lending, in the constructor up top, the very top, there you go. See, in the constructor we pass in an address of the token, and it's going to be the actual collateral token that we're going to use. So in our env file, the collateral token is the token contract address, so that's what we're going to pass in. Token contract address, and I think that should do it. Oh, constructor value required for, okay, I must have done that wrong, did I? Token contract address. Okay. Oh, you know what? Source.env. Clear. Wait one more time. There we go. Hadn't loaded the environmental variables. Copy this. That's going to be our lending contract address there. Okay. Let me clear that. Okay, so what we need to do now, we don't need my token anymore. Go back here. So the first thing we're going to do is we're going to deposit some tokens into our contract. Okay, now if we try to deposit tokens into our contract, as I've said here, we should throw an error. So the first thing I'll do is I'm going to do cast call or cast send, and it is token contract. Nope, it's not, it's lending contract. Getting confused. Address, and we're going to do deposit, and deposit takes in a uint, and we're going to say we want the deposit, and we'll just say 1 2 3 4 4 5 6. Okay, and we'll do private key, and we will say it's well, what private key will we use? Sorry, the private key, we say deployer private key. No, what we'll do is we're going to say token owner PK. Okay. Okay. So we're going to call cast send on the lending, or cast send on the lending contract deposit, and it's deposit. We deposit a uint 1 2 3 4 5 6. What we want to pass in token, and it's this, and we should get this. So we're getting an error here. So what's happening here is that this part hasn't been done. Okay, so what we really need to do is we need to call on the token contract. So we need to call cast send, and it's on token contract address, and what we want to do is we want to call approve, and I believe approve takes address and amount, sorry, address and a uint, and the address we're going to do it on is the lending contract address, and we want to say that it can spend as 1,000,000 tokens, so we're going to say 999,999, and we need to do that. So who owns the tokens at the moment is token owner PK. So what we're saying here is cast send to the token contract address, call the approve function, which takes in an address and a uint, and what we're passing in is the address to approve the tokens for is the lending contract address, and then we're saying give it 999,999 just to make it stand out. And there we are. So that's this part done. So we've done the approval. As I said, that's like when the approval pops up in MetaMask and you can say how much to allow the contract to spend on your behalf. And we've done that part. And if we go back here now to where we had our deposit, so we should be able to deposit into this. So what we're doing is we're going to interact with the lending contract. We're going to deposit the uint 1, 2, 3, 4, 5, 6. But this time, this contract that we've deployed, the lending contract, should be allowed to spend these tokens. And there we go. So we're after depositing into the contract. Okay. So that's that done now. And what I will do is I'm just going to call the total tokens in the contract, if I can find it here. So this should be 1, 2, 3, 4, 5, 6. Yeah, so there we go. So we know they've been deposited into the contract now. So the next thing we're going to just test is withdraw and see can we withdraw from the contract. 1 second now. There we go. Let's do that. So again, it's going to be cast send lending contract address, and what we're calling is withdraw, and that takes in the uint. And the uint we're going to withdraw. So 1, 2, 3, 4, 5, 6. I'm going to take 4, 5, 6 out because that'll make it nice and clean. Private key, and the private key again is token owner PK. That should do it. Yeah, there we go. And if we go back here, it should be 1, 2, 3, 0, 0, 0. Yeah, so that's spot on. So we're able to deposit into the contract and withdraw from the contract. And then if we get down here to borrow, and what have we got? So let me see. We could do cast send lending contract address, and we will call borrow. I can spell it right. Borrow uint, and it is. So what are we going to borrow? So we have deposited. So if we say 0, it should throw the first error. The private key. I'm going to say again token owner PK. This should throw the first error. So I noticed an error in the contract that I deployed. It's not a big one. We can actually just continue on. But if you see here, I've spelled borrow incorrectly. So when we're calling it on our contract, it's actually misspelt. So it's B-O-R-O-R-W. So otherwise it won't work. So we have we've 1, 2, 3, 0, 0, 0 in the contract tokens, and we're going to borrow 22,000. And so there we go, and there it's gone through. And now if we go back and we call this, it should be minus. So yeah, 101,000. So we're actually after borrowing 22,000 out of the contract. There. And now if we want to repay, clear, we're going to go cast send lending contract address. I'm going to say repay uint. I'm going to repay. Borrow 22,000, so we will repay 11,000 just to make it easy. And that's going to be private key token owner PK, and that should do the trick. Clear. If we go back, if we look here, it should be 11,000, or sorry, I borrowed 11,000. It's actually 112,000. Okay, so as you can see there, we have our functions implemented. They all work from the point of view of that you can deposit ERC20 tokens, you can withdraw ERC20 tokens, you can borrow them, and you can repay them. Yeah. Again, similar to the one we did yesterday, the ETH contract. you really are just, you're passing in one type of token as collateral, and then you're borrowing it up to the value. So it doesn't really make any sense from the point of view. But as the guys are saying in the brief, this is to get the structure of a lending and borrowing contract down before. I'm sure we're going to look at stuff like multi-collateral and multi-tokens. Like if you, with Aave, for example, you can deposit USDC and borrow USDT and so on. But this is obviously just the basic structure of how to deposit, withdraw, borrow, and repay.